are working on our last section, at least our last section for homework. And we should, I don't know, we might get it finished today. We definitely will get it finished by tomorrow. So I'm not too worried about speed. We're bang on schedule right now, as far as I'm concerned. So, quick summary of yesterday, all sine tan cos. That's something we know. All 6 trig ratios, we've used them before. Nothing too special there. Here's a few extra bits and pieces, some of which we've talked before. These are called identities. That just means, things that are equal to things simplified in trig. And sine squared plus cos squared is 1. I don't know if I mentioned this, but have I mentioned to you that the tan of theta is the same thing as the sine divided by its cosine? Well, no, I'm telling you, it is. Cosecant is the reciprocal of the sine, secant is the reciprocal of the cosine, and cotangent is the reciprocal of that guy. And we have kind of mentioned that even if we didn't get the thing. So, what does that mean? See if I know these 3 answers. Don't I just turn them upside down and I get these 3 answers? That's essentially what that means, right? And so there's a big bunch of questions, and that's where we're going to continue today with, which basically tell you one of these 6 trig ratios and the quadrant that it's in. And from that information, you're going to find all 6 missing trig ratios, or 5 of them are missing. So here's an example of that question. The good news is that you do them all the same way. So you're told that the cosine of theta is 8/90. And normally, well, about half the time, they tell you what angle theta's in, but not this time. This time, they're being a bit sneaky, which they like to be. They tell you that. So I am going to find all 6 trig ratios. I already know one of them for free, but I'm going to get the other 5. And the first thing I need to do is I need to find out which quadrant the angle theta is in. Because once I know which quadrant it's in, some of these are going to be positive and some of these are going to be negative. And the only way I can tell that is by knowing what quadrant the angle theta is in. So, first piece of information I'm going to use is that the cosine is a positive number. And if you're a positive number and you're a cosine, you're in the first quadrant. But where else are you? What other quadrant is the cosine positive?
The 4th.
The 4th. You see it there? Okay. And then you go to this thing and you say, oh, sine of theta is less than 0. That's just then saying the sine is negative. And I know that the sine is negative in the 3rd and in the 4th quadrant. You see, when you put those 2 together, doesn't that mean we now know where theta is? We've done questions like that before, haven't we? When you had 2 pieces of information and then it allows you to figure out which quadrant it's in. Now, once you've decided or found out which quadrant it's in, you just build a basic right angle triangle. I don't know why, but I like them that way around. And on that right angle triangle, you put a theta here, and then you name the sides. And we should be pretty good at this. This is the opposite. This is going to be the adjacent. And over here is going to be the hypotenuse. And the cosine is adjacent over hypotenuse. So to remind myself who is what, I write that down. And that makes the top number the adjacent, and it makes the bottom number the hypotenuse. So step 1, find which quadrant you're in. Step 2, create and finish off this triangle. Now you're always going to be able to get 2 numbers, right? Even if that says 5, won't you just call it 5 over 1 and you still get 2 numbers? But we have one more number to get. In this case, it's the opposite. And isn't that the Greek guy that killed the woman by throwing her over the boat, right? That guy, Pythagoras. And according to Pythagoras then, the opposite squared plus 8 squared is equal to 19 squared. So the opposite squared plus 64 is equal to 19 squared. So the missing side, the opposite squared, is take away 64 from both sides, and you get 297. I'm going to have to leave you for a second. My puppy Chloe is chewing something, and that is worrying because it's a funny noise, and that almost always means she shouldn't be chewing it. So I'll be back in 2 seconds. She was chewing this, so no problems. She can keep chewing that. I'm more worried that she finds electric cables and chews, because she would do that. So hopefully I haven't distracted you too much. To get the opposite, you take the square root. And in this case, since I want the exact value, I'm just going to leave it. I won't turn into decimal. There is no benefit, because these questions want the exact answer. Now, once that phase is done, you then enter your last phase, which is basically just find these guys. So,
I have a question.
Yes.
Would you want us to simplify the square root of 297?
Wow. Yes, but I can't see how to. Did you see something that works?
Yeah, 9.
9? Oh, well done. 9 times what? 39?
33.
33. Okay, so 3. Yes, I would, if you could see it. I just didn't see it. Yeah. So now we can move on and find the sine, the cosine, all 6 guys. Now, the numerical value is pretty much plug and chug, right? If I want to get the sine, it's the opposite, which is now going to be called that guy. So it's the opposite over the hypotenuse. So opposite over hypotenuse. And it's plus or it's minus. Now, the angle that we're talking about is in the 4th quadrant. Agreed? Will that sine be a positive or negative thing when the angle is in the 4th quadrant?
Negative, because also the question says sine is less than 0.
Right, which is a backup. Agreed? Right, the cosine I don't worry about because they told me that one. The tangent is opposite over adjacent, so opposite over adjacent. Is the tangent positive or negative? This one's probably a better one to look at. Is the tangent positive or negative in the 4th quadrant?
Negative.
Are we all comfortable about how we know that? All right. 4th quadrant, cosine is positive, the rest are negative. Okay, cosecant. Now, the cosecant is hypotenuse over opposite. Another way of thinking about the cosecant, isn't it? Just turn this guy upside down. And if you turn this guy upside down, you get that. Secant, well, if you turn this guy upside down, you get that. And cotangent, if you turn this guy upside down, you get that. Have you noticed that if I know these 3, aren't these 3 pretty easy to do? Right, just turn them upside down. Technically speaking, you could probably rationalize the denominator in these 2. I wouldn't, and the only reason I wouldn't do it is I don't think the answer's any prettier. Would you agree it's just as ugly that way as it would be if you rationalised it? You know, something like 4 over root 2. Yeah, 4 over root 2 I would rationalise, but not this one. Are we comfortable with this process? There are about, just a quick head count, how many questions are going to be like that? So this is going to be question 21, 22, 23, 24, 25, 26. So 21 to questions 26 are all pretty much versions of this one here, right? Do you feel comfortable if someone said cosine is this and something else, maybe that piece of information, could you find all 6 trig ratios? Okay, so all I'm going to do now is pick same question, but just a more awkward version of it. So I'm not going to give this a number because it's just one I'm making up. Suppose I tell you that the secant of theta is negative negative 12/5. Yeah, that's a good one. Yeah, I like that. And I tell you that theta is obtuse. So I'm giving you one of the less used trig ratios, secant. And I'm also telling you the piece of information in a very kind of vague way. So let's figure out which quadrant theta is in based on these 2 pieces of information. The secant of theta is negative 12/5, so it's negative. Isn't the secant the same as 1 over cosine? So what you're telling me here is that the cosine is negative. Does that make sense? You're telling me the cosine is negative. And I know that the cosine is negative in the second and in the third quadrant. Now, this guy here says that the angle is obtuse. How big is an angle when it's obtuse? Because it's in a certain range.
Greater than 90.
Right. In fact, greater than 90, but less than 180, right? It's just like a big fat angle. And that actually just gives me one choice. So it's the second quadrant. Are you comfortable with how we figured out that particular one was the second quadrant? In fact, couldn't have got the answer by just using theta is obtuse. Wouldn't that have been enough? The other choice, theta is acute. That's the other name they sometimes use. And acute angles are from 0 to 90. So that would be just telling me it's in the first quadrant, right? So they might just say theta's in the second quadrant. That's the best question, right? Or they might give you some clues. So far so good. Then we're going to
because
go.
it said obtuse, it's going to be in the third quadrant because it's between 180 and 90.
Yes, because it's obtuse, it's between 90 and 180.
All right, thank you.
Yeah, acute angles are angles like that. So any angle between 0 and 90, 90 is the kind of the changeover. Obtuse angles look like that. And they have the property that they're 90 to 180. So an acute angle is going to be in the first quadrant, an obtuse angle is going to be in the second. But now,
It doesn't include 180, right?
now 180 is a special case, just like 90 is. Isn't 90 a right angle?
Yeah.
So it's not really the first or second quadrant, it's kind of in the border. 180 is kind of, isn't it in the border between the second and third quadrant? But those are so special that you probably wouldn't do it this way, because if I knew the angle was 180, don't I know everything that I need to know to get all the other answers anyway? Right. If it's a specific number, I can get the sine and cosine. So here's my guy. There's my theta. I have an opposite here. I have an adjacent here. And we have an hypotenuse here. And in this case, the 12, the negative doesn't matter anymore. What is 12? Which one of these three guys is 12? And the way you do it is you look over here. Who is 12?
The hypotenuse.
Do you see that if you go to this formula here, it's a little bit clearer that you're talking about a 12 goes here and an adjacent goes here. And then we'll do Pythagoras next to find the opposite. So the opposite squared is going to be 12 squared, take away 5 squared, which is 144, take away 25, which I'm not going to risk in my head. And that's 119. And so the opposite is that one. I guess I should do a quick check. Does 3 do anything? Not 5, not 7. 7? Why would I do 7? No, it doesn't matter. 9, nope. 16, nope. 25. Okay, I don't think that one goes anywhere, right? So we're good on that one. So there's our third guy. Now I could do all 6, but let's just do a little snapshot. I want to know what the sine of theta is, right? That one. Well, it should be the opposite over the hypotenuse, which it is. And that ends up being the square root of 119 over 12. So the only thing I need to know now is positive or negative. What is the sine going to be in a second quadrant angle?
Positive.
Positive. And suppose I wanted to get just one more, the cosine. Well, the cosine would be the adjacent over the hypotenuse, and that would be 5 over 12. And in the second quadrant, what is the cosine? Positive or negative? Second quadrant cosine.
Negative.
Negative.
Negative. In fact, couldn't I just have turned this guy upside down and saved myself a whole load of talking? Right. Now, once you get the sine, cosine, and tan, and I suggest you always do these 3 guys first, right? Once you've got these 3, don't you just turn me upside down, turn me upside down, turn me upside down, you get the other 3, right? And that way you don't even really need to worry about formulas or worry about is it plus or minus, because isn't that already contained in here? Right, you already know if it's positive or negative because of the first 3. I'm getting pretty positive vibes from what I can see here, right? That it's a process, right? We're kind of comfortable with it. So you're going to prove me right. So I am going to give you 1 to do yourself. And here we go. In question 24, you're told that the cosine of theta is negative 11/13 and that the tan of theta is negative. No pressure. You got 4 minutes. Find all the trig ratios. close to the end here. Last few moments. Okay. We'll break the job into separate pieces. Let's do the first piece. What quadrant is angle theta in, based on the fact that the cosine is negative 11/13 and that the tangent is also negative? 2.
2.
I hear 2 in 2 different places, so let's check it out. The cosine will be negative in the second and the third quadrant, and the tangent will be negative in the second and the fourth quadrant, and so you nailed it. Now the cosine is adjacent over the hypotenuse, so hopefully the triangle that looks something like this, and you put in 11 and you put in 13. So my next question is, after you did Pythagoras, what was the length of the opposite?
4√3.
Sorry about that. I think I heard, does it 4√3 I heard?
The
No.
square root like 48.
Oh, square root of 48. Was that correct?
Yeah, but that can turn into 4 too.
And that's 16 times 3, so 16 times, no it isn't. What's 48? 16 times 3, it is 16 times 3. Oh God. So 4√3 after a lot of second guessing myself. Agreed? Okay, so the last stage is basically filling these guys in. I will get some of these done from you, or maybe one done by you, but let's just do the plus and minus thing. Since I know that the answer is in the second quadrant, right? So I know it's in the second quadrant. Isn't the sine and therefore the cosecant both positive? And won't the cosine and the tangent both be negative? And so if the cosine's negative, so is the secant. Are you comfortable about all the pluses and minuses and where they went? Okay, that guy there is 11/13 because we're told that one. What's the secant? So there's your first one. What is your secant?
(13/11).
You remember upside downs? If you know this one, you know that one. Okay, one last one, and then I'll fill in the rest. What's the tangent of theta?
Negative 4√3/11.
And so the cotangent would be
Negative 11√3/12.
do you mean 4√3?
No,
Well, it just turns into. if
Oh, yes. You rationalize the denominator.
yes.
And you are right. That is the rationalized denominator. I believe that the Weber sign is pretty generous, isn't it? About the rationalizing the denominator. Sometimes it doesn't care about it. Sometimes it does. So if you know you've done it right and it didn't like that answer, then you could rationalize the denominator. And I'm doing the easy one. I think it's the easy one anyway. The sine function is going to be 4√3/13. And the cosecant of it is just turn me upside down, which in its raw format is that. But since we're all good mathematicians, we'll rationalize the denominator, and we got that. Are we comfortable with that? I think it's stick a fork in it is done, right? So that bunch of questions where you're told one ratio and another piece of information so that you can figure out which quadrant it's in, that's all you need to get all 6 trig ratios. And we are finished with that type of question. So what we're going to do now, still on the same section, is, if you pause for a minute while I actually open up the questions, is we're going at the beginning of that section, which is a bit weird, but for me that just made more sense. We're now going to look at the earlier questions from that section, and they're, what's the word I'm looking for? Familiar. How about that? So you're going to see some questions and you're going to say, we've done that before, or at least it looks like things that we've done before, which is not a bad thing. So if I asked you to find the exact value of the cosine of 150 degrees, wouldn't you be running for that guy? And yep, we have done this before. I don't need to build right angled triangles, right? I don't need to do SOHCAHTOA or Pythagoras. Don't I just need to get my unit circle and find 150 degrees, and I get to here? Is it the x coordinate or is it the y coordinate? What is the cosine of 150?
Yeah, X.
And so our answer is that. Would you agree that is deja vu? We have done this before, right? And they do that. I mean, you know, they go back to things you've done before to get you comfortable with finding sines and cosines. So are you comfortable then that a cosine can be negative? In fact, haven't we found earlier today secants that were negative and tangents that were negative, right? So there's nothing too, I would say, too shocking about those questions. So let me tell you which ones they are. So questions 3 is like that, 4 is, 5, 6, 7, 8, 9, 10, 11, got it, because I'm further back, 15, 13. So they're going to be a big bunch of questions that ask you to find sine, cosines, tangents. Now, what they also ask you, which is a little bit less obvious, is that you might be asked to find some of the lesser used trig ratios, like the secant of pi upon 4. Now, I'm still going to use this guy. And there's more than one way tackling this question. Here is one way to tackle it. I'm not going to find the secant right away. What I'm going to find is its partner, right? The other guy. And isn't the other guy cosine, right? 1 over me. Now the cosine of pi upon 4 is here, and it happens to be root 2 upon 2. Now, once I find this guy, I can then figure out who that guy is. Isn't there a rule? Isn't the secant 1 over a cosine? Remember that? The secant is 1 over the cosine. So don't I just take this guy and turn him upside down? And now I know what the secant is. So I'm not finding the secant directly. What I'm finding is the cosine first and then turning upside down. Now, if you want to make that pretty, which I certainly would in this case, don't you get 2 root 2 over 2 and then the 2's cancel? Would you agree that rationalizing the denominator in this question is worth it, right? Because the answer is nice. So suppose I went and said to you, I would like to get the cosecant of 210 degrees. Who's the partner of this one? Sine, cosine, or tangent? Which one is the partner to this one?
Sine.
So I'm going to find the sine of 210 degrees. And I go here and I find 210 degrees. And would you agree the sine is the y coordinate? So it's -1/2. Now, once you've got this guy, can't we now get the cosecant by just turning them upside down? stuff we've done, adaptation of what we've done, just taking it a little bit further. Again, I'm getting pretty good vibes off that, but you know, I could be just picking up the wrong information. So how about this one? This is the cosine of negative 30 degrees. I can't find negative 30 degrees in my unit circle, and I need to use my unit circle. So what angle is the same place as negative 30 degrees?
330.
Do you want to tell people where you got that from? You're right.
I just went backwards.
Right. 30 degrees backwards. That works, right? Couldn't you just say add 360 if you were a purist, you know, and you wanted to do it as a calculation? Right. Now that I know that guy, don't I just say, okay, it's the x coordinate for a cosine. We've got that. Now, suppose they had said to you, the secant of negative 30 degrees. Right? Well, wouldn't you find the cosine, which is this guy, and then wouldn't you turn upside down? Because isn't a secant the upside down version of a cosine? And then you make it look pretty. I'm not quite sure if this is that much of an improvement, but there's the answer. How are we doing with this idea of finding sines, secants, cosecants of angles, not all of which are going to be in the unit circle? You feeling good about them? Right. Well, the best way to do that is to give you something to try. So I'm going to look at our homework and pick some questions similar to those ones. So how about question 9, which in my question is the secant of 120 degrees. Question 7, which is the cosecant of 315 degrees. And let's do a radian one. And question 11, and in my question, that's the cosine of negative 76 pi. Okay, no pressure. 3 minutes, 1 minute each. Go for it. And I've got my unit circle here. Hopefully your screen is big enough to read it. You're inside your last minute. No pressure. If you don't get all 3 done, I'm just going to fail you for the class. You know I'm not allowed to do that, right? Okay. Just so you know I'm kidding. Okay, let's try them out. I don't want the answer to question 9, the top one, yet. Can someone tell me what you find first and then tell me the answer? So in the secant of 120, what do I find first that will then get me the guy I'm looking for?
The cosine.
Okay, and what is the cosine of 120 then?
Would be the x. So
Yeah,
negative a half.
negative a half. I mean, you turn that upside down, you get -2, you're done. Right? Okay. The cosecant of 315 is not the guy that I'm going to get first. So who do I get first that's going to help me get that one?
The sine of 315.
Okay. And that's the y coordinate of this guy, isn't it?
Yep, so it's negative √2/2.
And when you turn them upside down, you get that. And then if you make it look pretty, I believe it eventually gets you to there. Does that look correct? Okay, I'll do the last one. The cosine of -7/6 pi is not in my unit circle. So I'm going to have to find an angle that's in the same place as it. You could just go backwards 7/6, but that's a bit awkward. So I'm going to go for, if you just add 2 pi to something, doesn't that get you to where you need to be? Right, so I'm just being lazy. So on my calculator, I would do, well, I guess -7/6 pi. No, I don't need the pi. Let me do it again. I just need the numbers. So -7/6, then add 2, and then make the answer a fraction. And I get 5/6 pi. And that better be in my unit circle. Wow, it's way up here. And it's a cosine, so it's the x coordinate. Okay. Any questions? So as long as I give you an angle that's in the unit circle or can be turned into somebody inside the unit circle, like this one here, are you comfortable you can find any one of the 6 trig ratios just from your unit circle? Okay, then we will call that done. So where are we off to next? Well, I think to finish with, we should finish with some simple questions. And the ones I'm talking about are questions 14, 15, I think it's also 16. Yes, and 14, 15, and 16 are essentially which quadrant is angle theta in? And let's do them. Question 14, at least my version. The sine of theta is greater than 0, and the cosine of theta is also greater than 0. And if you do all sine, tan, cos, the sine of theta is positive in the first and second quadrant. The cosine of theta is positive in the first and fourth quadrant. That means theta is in the second quadrant. Are you comfortable with that? We've done a lot of questions like that. Agreed? That's deja vu, right? Done it before.
In the
You
first.
put in the first quadrant.
What did I do? Oh, did you all catch that deliberate mistake there just to make sure you were watching me? I mean, look, I've got the answer with a big circle around it, right? Okay, now 15 is a bit sneakier. The secant of theta is positive, and the tangent of theta is also positive. Okay, if you tell me what the secant is, aren't you also telling me at the same time what the cosine is, right? Husband and wife. So secant is positive means the cosine is positive, and that is those 2 quadrants. The tangent is negative. Which quadrants is the tangent negative?
You put the tangent as positive.
Which quadrant is the tangent negative?
It would be the second or fourth, so it would be the fourth.
The quicker I go, the more mistakes I make. Right, last one. Version of question 16. The cosecant of theta is negative, and the cosine of theta is positive.
So the second quadrant, or the third quadrant.
You're ahead of me. You probably are right.
No, it'd be the fourth. Because cosine's in the fourth. Sorry.
Okay, let's find out. Cosecant is really the same thing as telling me what the sine is. If you tell me the sine is negative, you're telling me it's in the third or fourth, because it's positive here and here, so it's negative everywhere else. If you tell me the cosine is positive, it's positive in the first and it's positive in the fourth. And after your third attempt, you told me it was the fourth quadrant and you were right. Okay, the perfect time. I am getting really good at this. 10:15.